Hello, my name is Noor. I'm going to be covering the topic of tides and waves. I'm sure you are all aware of what tides and waves are, but I'm going to be introducing oceanography terms to ensure you understand the full processes that build up these tides and waves, and I will also cover their overall significance. Tides are one of the most reliable phenomena in the world. As the sun rises in the east and the stars come out at night, we are confident that the ocean waters will regularly rise and fall along our shores. Tides are very long period waves that move through the oceans in response to the forces exerted by the moon and the sun. Tides originate in the oceans and progress towards the coastlines where they appear as a regular rise and fall of the sea surface. When the highest part, or the crest, of the wave reaches a particular location, high tide occurs. Now, low tide corresponds to the lowest part of the wave, or it's called the trough. The difference in height between the high tide and the low tide is called the tidal range. Tides are also called forced waves because they are never free of the forces that cause them. Although there's a pull force towards the moon, there is an equal force going the opposite side of Earth. Earth's motion creates this opposing bulge effect. This opposing bulge effect is caused because of the centrifugal force around the center of mass of the Earth-Moon system, which is called the barycenter. But that is in regards to another topic, which can be described later. Something important to note is that the pull of the moon is 2 times more important and stronger than the pull of the sun in terms of affecting tides. The relationship between the masses of the Earth, Moon, and Sun and their distances to each other play a critical role in affecting the Earth's tides. Although the Sun is 27 million times more massive than the Moon, it is 390 times further away from the Earth than the Moon. Tidal generating forces vary inversely as the cube of the distance from the tide generating object. This means that the sun's tidal generating force is reduced by about 59 million times compared to the tide generating force of the moon. Therefore, the sun's tide generating force is about half that of the moon, and the moon is the dominant force affecting the Earth's tides. The reason why tides rise and fall is also because the oceans are fluid, meaning they respond to changes in gravity and rotation, linking back to the sun and moon effect of gravitational forces. Spring tides are essentially strong tides. They do not have anything to do with the season spring though. They occur when the Earth, the sun, and the moon are in line. The gravitational forces of the moon and the sun both contribute to the tides. Spring tides occur during the full moon and the new moon. Smaller tides, called neap tides, are formed when the Earth, sun, and moon form a right angle. This causes the sun and moon to pull the water in 2 different directions. Neap tides happen during a quarter or 3/4 moon. To give a geographic perspective, the tropics regions of Earth have smaller tidal ranges. On the other hand, regions such as the end of the Pacific Ocean basin have large tidal ranges. Patterns of ocean basins vary depending on water moving in and out of ocean basins. Basically, the center of the ocean has smaller tidal ranges, and closer to continental boundaries have larger tidal ranges. You might be asking yourself, why do tides matter? They matter because they affect beach communities, marine organisms, and storms. If a storm surges and there's a very high tide, then it can lead to a giant natural disaster for people who live around coastlines. They're also important because some organisms have tide-based rhythms. Example, California grunions, which are beings that come ashore to lay eggs just after highest spring tides. Furthermore, the width of the shoreline strip that is affected by waves depends on the tidal range. Another thing that's important, basically. A large tidal range means that a wide strip of land might be subjected to the force of the waves. If the tidal range is very small, however, all of the wave's energy will be concentrated in the same place. So, we now know that tides depend on waves as well. Waves are essential to understand. Before we delve into that topic, let's start off by drawing a couple of waves and labeling their features as today's lesson activity. So right now, I want you to start off by drawing a wave that looks like that, big waves basically, and small waves that look like that. Now, once you're done doing so, I want you to label or draw a circle specifically at the highest points of each of the waves. These are the highest points, as you could see, right, where the dots are. This is called the wave's crest. Once again, it is the highest part of the wave. It's called the ocean crest, or the wave crest, basically. Now, the lowest part of these waves, determined by the lines, as you could see here, is called the wave's trough. Once again, the lowest part of the waves is called the wave's trough. Now, the distance between two crests, of a wave, or two troughs of a wave, is called the wavelength. Once again, to determine the wavelength, you have to look at the distance between two crests or two troughs. And now the most essential part is to realize the motion of the wave, which is like this. It's an orbital motion, meaning that the wave performs a circular motion. Now, to give you a more detailed approach, it has an orbital path of individual water molecules at the water's surface, basically saying that the wave performs a circular motion towards the surface of the ocean, not towards the deeper parts. Now, as a final test, I want you to draw one last wave pattern, and I want you to label where the crests are, where the troughs are, what kind of motion the wave performs, and where the motion is located, either at the surface of the ocean or at the deeper parts. And once you've done that, then you have successfully completed today's activity. Now you know how to draw a wave and where its ideal traces are located. I am now finished with my specific part. I hand the video over to Michael, who will now talk about waves.
Now that we have learned about tides, we are going to be discussing waves. What is a wave? The definition of a wave is a disturbing force that causes the movement of energy through some medium. This means that if a rock is thrown into a still pond, for example, it creates a disturbance that generates waves radiating out in all directions. Ocean waves are caused by a similar transfer of energy to the surface of the ocean. In a wave, the highest points are called the crests, and the lowest points are called the troughs. Halfway between the crests and the troughs is the still water level, or the zero energy level. This is the level of water if there were no waves. The wave height is the vertical distance between the crest and the trough. Waves can travel great distances across ocean basins. In one famous study conducted in 1963 by a team of researchers led by Dr. Walton Munk at the Scripps Institution of Oceanography, waves generated near Antarctica were tracked at various points as they traveled across the Pacific. After more than 10,000 kilometers, or over 6,000 miles, the waves finally expended their energy, or broke onto the shore, about a week later along the shoreline of the Aleutian Islands of Alaska. The result of this study, and many others, indicate that water itself doesn't travel the entire distance, but the waveform, or the graph of the wave movement or energy, does. As the wave travels, the water passes the energy along by moving in a circle. This movement is called circular orbital motion. In simpler terms, ocean waves are orbital. The particles travel in an orbital fashion as the wave passes, and the water does not necessarily experience much horizontal movement. So how are waves generated? As the wind blows over the ocean surface, it pushes down on and parallel to the surface, causing water to pile up into small wavelets called capillary waves, which are more commonly called ripples. As the wind speed increases, the height and wavelength of the waves increase as well. They begin as capillary waves and progress into real waves. When the wave's steepness becomes too great, the waves become unstable and break. The energy imparted by the wind increases the height, length, and speed of the wave. There are only two factors that determine the amount of energy in waves. These factors are wind speed and duration. An interesting fact is that waves cannot get any bigger during the same wind conditions. So, after 3 days of constant wind, the waves are at their max height and cannot grow any larger unless the wind speeds increase. Most waves generated in the sea area by storm winds move across the oceans. These waves then release their energy along the margins of continents in the surf zone, which is the zone of breaking waves. Breaking waves exemplify power and persistence, and they can sometimes move objects weighing several tons. In doing so, energy from a distant storm can travel thousands of kilometers until it is finally expended along a distant shoreline in a few wild moments. We're going to break this process down into 4 steps. Step 1. When the water depth becomes half the wavelength, this becomes a shallow water wave, and the motion starts to become elliptical. Number 2. The wave crests peak because the wave's energy is packed into less water depth, and the wave height begins to increase. Step 3. The wave speed slows underneath the water, and the whole wave begins to slow down. Step 4. The wave height increases even more until it becomes unstable and topples over or breaks into a breaking wave. Depending on the steepness of the seafloor near the shore, the waves can be a spilling wave or a plunging wave. A spilling wave occurs on a gentle seafloor slope. As the wave approaches the shore, it slowly releases energy, and the crest gradually spills forward down its face until it is all whitewater. A plunging wave occurs when the ocean floor is steep or has sudden depth changes near the shore. These can be powerful barrels and are most likely the pictures you see of surfers riding inside of waves. I hope you learned a lot about waves and tides today. Thank you.